Indirect proofs are often used to prove concepts in number theory. Write an indirect proof to show that if x squared is an odd integer, then x is an odd integer. Drag the correct statement to each bin. So we are given that x squared is an odd integer, and we're proving that x is an odd integer. So to do the indirect proof, we're going to assume that x is an even integer, right? Because we want to take the opposite of what we're proving to prove that what we're proving is correct. To assume that x is an even integer means that x equals 2k for some integer k. Okay, so x squared equals 2k squared. We're going to just sub 2k in for x, which means that we have 4k squared, which is 2 times 2k squared, which is 2 times the quantity 2k squared. Now determine whether 2 times the quantity 2k squared is an even or odd integer. Because k is an integer, 2k squared is also an integer. Let n represent the integer 2k squared. So x squared can be represented by 2n, where n is an integer. That means that x squared is an even integer, which contradicts the given statement that x squared is an odd integer. Because the assumption that x is even leads to a contradiction of the given, the original conclusion that x is odd must be true. Watch out. Proof by contradiction and using a counterexample are not the same. A counterexample helps you dispose of the conjecture. It cannot be used to prove a conjecture. And your study tip for this video? When working with algebraic proofs, it's helpful to remember that you can represent an even number with the expression 2k and an odd number with the expression 2k plus 1 for any integer k. So anytime you have to represent an even, use 2k, and anytime you have to represent an odd, use 2k plus 1. Make sure you get that in your notes because it'll be helpful later on.